Hello there, my name's Steve Warr and I'm the course team leader for A-Level Maths and Further Maths. So welcome to this presentation about the summer work for maths. I'll also say a little bit about further maths at the end. So for those of you who are doing further maths, we're going to ask you to go through the summer work for the maths course first, and then there'll be a little extra task for you to do in a separate file. You can find both those files to download from the college website. So what we're going to do in this video is just think a little bit about what the purpose of this summer work is, and I think that's going to help get you prepared for your lessons in September. What we're going to do then in our lessons is three main things. We're going to learn to apply standard maths techniques, we're going to learn to do some problem solving, and we're also going to take some situations in context and learn how to translate those into mathematical models. Okay, now if we're going to do this effectively, we need to have what's called deep learning in maths, because people don't always think about maths as being a creative subject, but it is. So you've got to have your basic knowledge, and you've got to learn how to apply these techniques that you've already mastered and reason through similar problems that you've not really seen before. But you've got to take the approaches that you know how to use and apply them to a novel situation. And above all, you just got to be prepared to persevere in when the problem solving gets really difficult. So what we've done is we've divided the summer work up into a number of sections. So we're going to start off with 4 sections of relatively routine sort of basic skills work. So I've picked indices and surds, linear inequalities, and some work on quadratics. So that'll be factorising, completing the square and graphs and so on. So you can see on the right hand side there, I've shown you the questions we've got on indices. So you may feel confident with those, in which case you can just have a go at writing out your answers. But if you're looking and you think, well, I'm not quite sure, and I think I've got a bit rusty on this, you'll see at the top here, there's some link to some supporting videos. And if you click on that link there, that will take you to some quite detailed presentations going through the whole of the topic of indices. And you'll be able to have a little look through those and see which ones you want to look at and just fill in some of those gaps in your knowledge. Okay, so once you've done the 4 sort of basic skills sections, there's then some modelling work. Now that's getting a little bit harder, and you're going to have to learn to actually use all the knowledge that you've had from the earlier sections to help you do that. And then we're going to do some more unusual problem solving at the end, just to get you thinking about maths in a little bit more of a creative way. So this is the problem solving example. There's actually 2 we've got for you, but this is an example of the first one. So you'll probably look at this and you won't be quite sure what to do. Let's see if I can get my little interactive pen to work. So here you've got like a little surd expression. You might start off by looking at the whole thing, and it wants you to come up with an answer for that without using a calculator. And that's not really quite obvious where to start. So the other thing just to explain to you is those little dots there in the middle. So we've got like 3 terms shown here. We've got the first term and the second term, then we've got some dots, and then we've got a last term over here. So what the dot means is there's a load of extra parts which have not been written. So what you've got to do is to start looking for some patterns. Just see how the numbers are working, and then think about what the next term is and the next one, and just try to write out a few of the patterns, a few of the terms that we've not included. And then you've got to take a step back and then start looking at one little part of it, like that part, for example, and think, well, what could I do with that? And then go through the same process for some of the other terms, and then just think about what you see. Is it going to help you to actually come up with an answer? Because we want you to do it without a calculator. Okay, and then there's a little thing at the bottom there that says, can you find some other sums with surds when you get whole number answers as well? Because it might surprise you that comes out to be a nice simple whole number. And the question is, what value does it take? Okay, so that's the sort of thing we'll get you to have a look at when you finish the earlier parts of the summer work. Okay, so most important thing is I think I want you to enjoy these tasks. but just be careful you don't leave it to the last minute, because you'll find that you need to build in some time in your schedule for getting stuck. Okay, and you may even feel at times that you're not making any progress at all. You're looking through the videos in those links I said, and you're trying to find a question that's similar, and you can't really find one. And you just think, well, I'm just not sure what to do. And you might feel like I've spent an hour and I haven't done anything. It's sort of wasted time. But it's really important that you realise that you haven't wasted your time. Okay, you've got to build into your schedule thinking time and just time for being stuck and for sort of trying to get your head around things, because that's all part of the process of becoming a more effective learner. So please give yourself time to do this work and don't leave it to the last minute. So what I would like to do now, before we move on to the next slide, is just emphasize the importance of getting really fluent with the basic skills, your surge, your indices, your quadratics and so on. From those harder GCSE topics, those are going to become the absolute basics of the A-level course, and you just need to get really, really skillful at using those. And we sort of think about them sometimes as the scaffold, if you like, to help you think about harder questions. And what I'd like to do now is just to illustrate. This is like an A-level question, and I'm just going to sort of go through it a bit with you, just to illustrate the process of trying to use some of the knowledge that you've had and you've been learning about. So it says use algebra and show each stage of your working to find all the real solutions to the equation 2x plus square root of x minus 6 equals 0. Okay, now you might think, well, okay, I know how to do that. Or you might be thinking, I'm not sure, I'm just completely stuck. So what I'm going to do is I'm just going to click on that little box just there. And I'm going to see if I can get my little interactive pen to come up so I can write. There we go. So we normally have two ways of approaching equations. You can think about them graphically and you can think about them with algebra. So what we've got here is a line in red and a curve in yellow. So what we've done here is we've taken this equation and we've rewritten it in a slightly different way. What I've done is I've left the root x and I've moved the 6 over the other side of the equals, and I've moved the 2x over the other side of the equals, and that equation is equivalent to the one we started with. So what you do is you say, I'm going to draw two graphs. I'm going to draw a graph for the left-hand side, which is that one, y equals root x, and I'm going to draw another graph for the right-hand side, which is that one, y equals 6 minus 2x. And actually, those two graphs, they cross at that point just there. And what this question really wants to know is, what is that value of x? Because this is the x-axis. Okay, that's the y-axis. We want to know what the value of x is where those two graphs cross. And that will give us the solution to this equation. So that's one way you can think about this. If I click on that one, you've also got an algebraic approach to do it. And that's what the question actually wants us to use, because it does actually say here, use algebra. So sometimes it's nice to visualize a picture so you know what it is you're trying to do. Now you can see here that we've got to make use of our skills with surds and also with indices as well. So this is one of the sort of basic techniques that we'll teach you on the A-level course. So what you do is you take the awkward bit, which is that, and you change the letter and you say, well, let's let u be the awkward bit, square root of x. Now, if you've been doing your indices work at school, you will realise that one way to write the square root of something is to use a power 1/2. So we'll learn a bit more about why that is during the course. But x to the power half, we're going to call that u for the square root of u. Okay, now what you need to realise is that this equation here, 2x plus root x minus 6 equals 0, we can rewrite that using this substitution and make it an equation involving the letter u. Okay, so what we're going to learn is that when you've got the expression like 2x, when we look at u being root x, if we square both sides, so that will be u squared, and when we square that, we get x. So really, we can replace the x by u squared, and so 2x will be 2u squared. Okay, and then that square root of x in the middle, well, we just call that u, and then the -6 on the end, that's not going to change. So this equation here in x, which is awkward, we're going to write it as 2u squared plus u minus 6 equals 0, just by using a little trick with indices and thirds. Okay, and we've now got a quadratic equation. And that's another one of your basic skills. So we solve those, if we can, by factorising into brackets. So that's another thing you're going to have to get really fluent at, putting the two expressions into the brackets. And then when you put them equal to 0, well, each bracket in turn has to be 0. So that would give u is -2. And that will give u equals 3/2. Just doing that quickly in my head. Okay. Now, we're going to take the positive value of u, so we're going to use u is 3/2, and then we're going to remember that u was a substitution, and we've got that u squared is x, and so x has to be the square of the 3/2, so we need to take the 1.5 and then square it to get the 9/4, which is then given as u. So going back to the picture, those two graphs cross at the value 9/4, and that gives us the answer to the problem. Okay, so there's an example of a relatively straightforward A-level question when it wouldn't really be very clear what you have to do, but you can see there an example of using the basic skills, which are like GCSE skills, but they're now being used in a slightly more novel way. And the more experience you get at solving these sorts of problems, the more skillful you get, and then you'll find it gradually gets easier. Okay, so I thought that would be a nice little thing to show you. Okay, so the thing I want to mention in this slide was it's really important that you just get used to, and you expect to get used to, engaging with unfamiliar problems. That problem I just showed you is possibly something you've seen before, but it's likely that you haven't seen that sort of thing before. And that's going to be a typical thing in a maths classroom. Virtually every problem you're going to see has got to have some features about it that make it slightly awkward. Okay, so I want to give you plenty of time over the summer to go through this task, and then we're going to ask you to submit it on A4 paper in September, and then your teacher will mark it for you and give you some feedback. So it's really important, as it says at the bottom there, that you write your solutions out nice and clearly so other people can follow what you're doing. Okay, now when you're doing the questions to start with, we don't expect you to write everything out nice and neatly, because you're just jotting your ideas down and trying to get your head around the question. So at that stage, it's perfectly okay just to do things in rough. Now, if your rough work is quite neat, then you can probably hand that in. But if it's not, then once you've finished your rough work, you ought to rewrite it out again from scratch on A4 paper and actually make sure it's nice and clear and your steps are easy to follow, and try to work down the page rather than going across the page, because it makes it so much better to read. Okay, so that's what we'd like you to do for September. Now, lots of students get easily distracted, and there's this word called procrastination. And lots of students feel like they procrastinate. They put things off. They think, well, that's going to be hard. I'll do something a bit easier, and I just don't want to do it. Now, if you're one of those students, there's a really interesting podcast from one of the BBC Sounds apps, and you can click on this link, and I think it's well worth listening. It's well worth a listen, because it's very, very interesting. Okay, and if you want a little bit of advice just to help you get started, just set yourself some small goals to help you get started, and just don't be too hard on yourself. Okay, and if you want any more advice about how to get started, or any advice with the maths, if you're finding some of the questions a bit hard and you've looked through the videos and you're still not sure what to do, then just please send me an email and I'll give you a little hint. Okay, now that's the maths part of this presentation. I've just got one last slide for those of you who are going to do further maths. Now, when you do further maths, that's the second A level on top of the maths. So we'll ask you to go through the maths summer work first. And when you've completed that, there's just an extra supplementary question, which is also a file that you can link to on the college website. So there's only really one question for that, which is split into 3 parts. So I'm just going to give you a little hint for this, because it's actually quite hard. So the first thing is you've got a circle here, and these 2 lines here are called chords. and they've just labelled some of the lengths A, B, C, D, and the question says show that A times B and C times D have the same answer. So you might be thinking, I'm not sure how to do that. So if you want a hint, go onto Google and do a search for the alternate segment theorem and about how it's used to get something called the intersecting chord theorem, because that first part of the question is all about the intersecting chord theorem. Okay, don't just write the intersecting chord theorem down. I want you to actually prove it. I want you to actually, it's called derive it. Come up with a bit of maths using your circle theorems from school and actually show the result A times B equals C times D. Okay. Now the second problem, you've got the large yellow circle and you've got two smaller circles inside, and it's got some information in here that it tells you that all the circles touch, and the centres of all the circles are on the line AB. So you've got the centre of the small circle and the middle-sized circle, and then the large circle, the centre's somewhere in the middle. Okay, now you're told the length of CD is 8 units, and the question wants you to work out the area of the yellow shaded region. Okay, now to give you a little hint on that one, just assign some letters to the radii of the circles, and then I need you just to think a little bit creatively to see if you can make a link between that second question and the first one, because the first one is there to help you do the second one, and that's where the creativity comes in. Okay, and then once you've done that, you've got the last part of the bottom. So this time the two circles inside are shaded blue, so you've got the slightly darker blue and the slightly lighter blue shading, and it says that the area shaded in yellow is equal to the area of the larger of the two circles shaded in blue. And it says, what is the relationship between the radii of the three circles? Now, when it says what's the relationship between, you could think about that in lots of different ways. Perhaps the easiest way to think about it would be to say, well, what's the ratio of the sizes of the three radii of the circles? Because if you can establish that ratio, that's given you a relationship. Now, maybe one circle is has got a radius that's twice as big as the other, for example. So trying to think about what the ratio is between the radii of the circles, and that comes out of the fact that the yellow shaded region and that dark blue shaded region have to be the same. Okay, and once you've finished the problem, if it's been done and it's quite jotty, I want you to write it up nice and neat for me so I can follow your reasoning, and then you can submit that as on top of your maths summer work as well in September. So that brings me to the end of this presentation. I hope you enjoy doing the summer work. Make sure you give it plenty of time, and I hope you found that presentation informative. So I hope you enjoy the summer, and we'll see you in September. So goodbye.